So in this today's lecture, the eighth lecture, today we are going to design a robot, right? So in yesterday we saw how to wire the output components. That means how to wire the DC motor to the Arduino, the controller, right? The L298N motor controller is used to control the motors, right? So you know that, and you know how to connect those things, right? So while we use those things, we have to today we have to create an object. That means today we are going to create a project, actual project, right? So today in this class we are going to make that one. After you learn from this class, you can make that robot, right? So this is what we are going to design today, right? Design an obstacle is our obstacle avoiding robot, right? Obstacle avoiding robot we have to create, right? So how can we create? This is how it look like, right? So hope you know that this is how it will look like. So this is the motor, right? So we have two motors, two DC motors. Those motors are arranged with two wheels, right? After that, we have Arduino and the L298 motor controller and the battery, right? So you can use this battery also. This is not a rechargeable one, right? But I am suggesting you to use rechargeable batteries. So then if you use those batteries, if the batteries are drained out, you can recharge them, right? So this is the robot that we are going to design today, right? So design after the class, you have to make this robot actually, and the working video you have to send it to me. That is the task from this class. Okay, so you have to manually make this robot, right, from your home, and you have to take a video of that robot, and then you have to send it to me. That is the tomorrow lecture's purpose, right? So this is very simple. If you learn these things, this is very simple, right? So little bit considered. So if you watch the class attentionally, that means you will learn these things, right? So that is it. You know that how to wire up the output components, right? So similarly we can also wire the components as well. So I am going to design this one by using our Tinkercad software, right? So I'm going to explain it to you by using the Tinkercad software so that you can understand this very easily, right? So if you have doubts regarding connecting and designing the things, you can cross talk with me and ask questions, right? Right, let's get into the video. Right, I'm going to go to the Tinkercad software. Right, after that, I'm going to click circuits and create a new circuit. Right. Right. So what do you mean by obstacle avoiding? Obstacle avoiding means we are going to design a robot, right, that will be moving, right? Simply the robot will be moving, but while it is moving, if there any object is present, right, so then the robot should turn, right? So that is the task, right? So how can we make those things? So simply I'm going to simplify these things by assuming that, right? So I'm going to assume that if any object is present, the robot should turn to the right side, right? That is the task. That means I'm simply explaining to you, right? This is our robot, right? Let's say this is our robot. We have two wheels here and all the components and here, right? So after we have designed and after we have programmed this one, the robot should move in forward direction, right? In this direction, it should move, right? So while it is moving, there may be some objects, right? So there may be walls or something, right? So if there is any object is present while its path, it has to turn in this direction. That means it has to turn in right right direction, right? So while after the robot is turned on its right side, even when another object, right, another whatever may be object, right, it's detected in its path, it also has to turn in this direction. That means it also has to turn in this right direction. Eh? This one is right, right. So it has also has to turn in this right direction. This is the simple task that we are going to design today. Right? I'm going to explain this circuit by simplifying this. Right? If you learn very attentionally in this class, you will learn the complex parts also, right? So that is why I'm simplifying this for all of you to understand, right? After you understand the programs and how we can make these things, you can make it larger. That means you can you can make the robot, if there is any object is present in its way, it can turn on left side, right? And if it is an object, it can turn 180 degrees as well, whatever, right? So if there is any object is present, it can turn on 180 degrees, it can turn whatever we want, we can make it, right? So I am going to simplify the problem and explain it to you, right? So then you can understand these things very well, right? So for that, so for the new people, I'm going to tell it to you again, right? So today in this class, we are going to learn about how to make an obstacle avoiding robot. That means if the robot is moving, if there is any object is present while it's moving its path, right? The robot has to turn on this right direction, right? That is what we are going to learn today, right? Right. So if you have any questions, you can ask me, right? Right. So I'm going to clear this, right? So do you have any idea about this one? So do you have any ideas or suggestions in order to make this obstacle avoiding robot? Any suggestions or hints you have? Anyone? Right. So for that, I'm going to make a proper table, right? So that you can understand that very easily, right? So I'm going to make a table. For that, you can understand this very easily. Right. Sorry. Right. In this table, I'm going to create it, right? So this is the task, right? So if any object is detected, right? That means if any object is detected, that means it has to turn on right direction, right? It has to turn on this right direction. If no object is present, what will have to do? If no object is present, the robot should move forward, right? So did you understand this thing? So do you understand these things? So please let me know, right? So this is what we are going to do, right? So if there is any object is present, right? So if there is any object is present, the robot has to turn in its right path, right side. If there is no object is detected, the robot should go forward, right? That is the particular task we are going to design. Right? So if you understand this one, only you can program. Otherwise, it will be like watching movies, right? So if you understand these things, only you can code it, right? So for that, the sensor that we are going to use is, so also you can see the images of obstacle avoiding robots, right? So hope that you can get more idea. So these are the obstacle avoiding robots, right? So these are different robots, right? So I'm going to. So hope you see this one. So this is the obstacle avoiding robot. You can see that. So in the head of the robot, and the ultrasonic sensor is mounted, right? So here they have also mounted a servo motor here. But here in this particular case, we are not going to focus on the servo motors, right? So only the sensor is mounted on the front face of the robot. That's up, right? So after that, we can increase the complexity and make programs, right? So today, the sensor is fixed on its front face, and then the robot should go forward. If there is any object is present, the robot has to turn on its right side. That is the task, right? So let's get back. Right now, for that we have to insert an Arduino here, right? So we have to have a Arduino board here, and we can simply place here, right? Then after we have to insert a breadboard, right? So breadboard we can insert here, right? So breadboard is also there. So what are the other components that we need? Just answer me. What are the other components that we need to achieve this task? We have ultrasonic sensor, right? We have to have an ultrasonic sensor, right? So some may have 3-pin sensor. So basically, you may have also 4-pin sensor, right? So I'm going to obtain a 4-pin sensor, right? So that is not a problem, right? I'm going to obtain a 4-pin sensor, right? So then after, we have to have what? We have to have two motors. Sorry, motors, right? So we have to have these two motors, right? So these motors are the output components, right? So you know that how the motor will look like, and then you have to insert the wheel with its motor, right? So that the motor will be rotating according to our program. So these things very easy, you can understand, right? What are the other things that we have to have? We have to have a motor controller, right? So in this particular software, we don't have that particular motor controller. That means L298 motor controller. Why I selected the L298 motor controller? That is the basic component that you can get very easily from your nearby electronic shop, right? That is why I'm using that one, right? So that is a very easy thing to understand. That is also why I used that one, right? So here we have to insert a battery, right? So I can use a power supply instead of the battery, right? So you can also, yeah. I'm going to create all components, select all components, and then we can type simply a power supply. Right? So you can simply drag here and drop there. So you can simply adjust the voltages as well. So if you don't have the power supply with you, what will you have to do? You have to insert a battery there, right? So simply you can select the rechargeable battery, and then you can connect it as well, right? So for the working purpose, I'm inserting here, right? So hope you understand this one, right? So I want to simulate this component and show it to you, right? As a students, you have to understand this about how it works, right? So I'm going to simplify and show it to you how this will actually work, right? For that, I'm going to delete these two motors, right? And I'm going to insert a LED bulb there, right? Instead of this motor, I'm going to insert LED bulbs, right? So simply I can drag here, and another LED bulb I can drag on the right side, right? So that means this LED, if the LED is turned on, that means the motor is turned on, right? So if this LED is turned on, that means this motor is turned on, right? That is the case that we are going to use. But in our motor controller, in order to rotate this motor, what will we have to do? What will we have to do? Because we have to use a motor controller. So in order to use that motor controller according to our requirement, we have to connect the motor controller with proper pins. That means in 1, in 2, in 3, and in 4. Right? So how can you make these motors to rotate? You can simply power up in 1 pin and in 3 pin. That means if you give the power to the in 1 pin and in 3 pin, that means both the motors will be rotating towards forward direction, right? So on the other way around, right? So if you give power to in 2 pin and in 4 pin, that means you are changing the direction to motors to run backward direction, right? So hope we understand these things. So how can you make this robot to rotate or turn to the right side? Can anyone tell it to me? How can we make the motor or the robot to turn to the right side? Can anyone tell it to me? Anyone? So just answer me whether it is correct or not. It's not a problem. Don't worry about the recordings as well, because we all are students. So I'm not going to share the class recordings to other people, right? So the class recordings will be provided only for you. So if you are shy to answer questions, that means you will never going to learn these things. No matter it is correct or not, just answer my questions, right?
So using motor?
Yeah. So how can we rotate the robot to the right side? So how can you give power? That means I'm asking simple question, right? So how can you power up? That means are you going to give power to in 1 or in 2 or in 3 or in 4? Or what are the pins that you are going to power up? Give power. That is what I'm asking. Yesterday also I asked the same question. One person answered correctly. Today also I'm asking the same question, right? So these are very simple things, right? So if you practice these things, these things will be very easy, understandable, right? So what we have to do in order to turn this right side, right? So we have two motors, right? So in order to turn the robot to the right direction, what we have to do? We have to only give power to this motor to rotate forward, while remaining the motor is not rotating, this motor, right? So we have to stop this motor and rotate this motor. That means the robot will be rotating in its right direction, right? That is why. So you know that, right? So here you can see that, right? So this motor, that means this motor is not rotating. This motor is rotating. What will happen? While it is stopped, the right side motor is rotating. What will happen? The entire robot will turn in this direction. That means left direction. Right? Similarly, right, we stop the right side motor and rotate the left motor. What will happen? The robot will turn right direction. That is what I'm going to do. Right? So this is very simple, right? So did you get my point? So I'm going to do it another way, right? So I'm going to ask questions, right? So first, Binuka, right? So Binuka, can you please turn on your mic and answer my question? So what do you understand about this in 1, in 2, in 3, and in 4 pins? I'm just asking, what is your perspective about in 1, in 2, in 3, and in 4 pins? Binuka, can you answer me?
There are different types of inputs.
Sorry, your microphone is not clear. Can you increase the volume a bit? Maybe I can.
Now, can you? Hello.
Yeah.
So,
Yeah.
can you?
Yeah, I'm hearing. Yeah, I'm hearing.
The inputs are like different types of
So where these pins are located? In 1, in 2, in 3, whether it is in Arduino or other.
in the digital and analog sides.
No, not there. These pins in 1, in 2, in 3, and in 4 pins are located at the motor controller, right? Motor controller means this one, where he have this one. So in here, this is the motor controller, right? So this is the motor controller. Motors are connected in this side and this side in this motor controller, right? So here in this pin we have in 1, in 2, in 3, and in 4 pins, right? So this is what I'm talking, right? So I know that you are a little bit confusing. That is why I ask questions, right? So again, Buani Tisar, right? I'm going to ask you a question. Can you unmute yourself and answer my question? This is the second question, right? So after you identify in 1, in 2, in 3 pins, where will you connect these pins? Where will you connect these in 1, in 2, and in 3 pins? From where? Can you answer me? Buani Tisar. No matter if it is correct or not, no matter, just answer me. Right. So I'll tell the answer, right? So in 1, in 2, in 3 pins are here. That means it is inside in the motor controller, right? So these pins are directly going and connected to the Arduino. That is the answer. That means in Arduino, right? Another person, right? Ginure Gikianagi, right? So in Arduino, what pin will you connect? That means I'm asking simple question: digital pin or analog pin? Yesterday we learned these things. That is why I'm asking little simple questions. Can you please answer me? Ginura Gikianagi. In the Arduino, we are going to connect these pins. That means in 1, in 2, in 3, in 4 pins, and then we obtain a jumper cable and connect it to the Arduino, right? In the Arduino, where will you connect? That means in the digital pin or in the analog pin? Simply answer me. Yeah, to the digital side, of course, right? So we are going to connect these things to the digital pin, right? So that's fine, right? Because in1, in2, in3 pins are obtaining what signals? Digital signals. That means it may obtain 0 or it may obtain 5 voltage. That's up, right? So that after we have wired up, what will we have to do, right? What will we have to do? We have to wire up the sensors and all the other stuffs, right? So that's stuff, right? So I'm going to, right? So I'm going to wire up these things, right? So shall we wire? Right. So a little bit here, right? So I'm going to give the power, right? So maybe the power supply, negative, positive voltage can be connected to the this one. Right? So basically, this is not the original way. That's what I'm thinking. Uh, right. Maybe I'm going to explain it to you, right? So if you learn the original thing, you can make a lot of things, right? So I'm going to obtain power from the power supply, right? So I'm going to obtain power from this one is positive, so I'm going to connect positive. This one is negative, and then I'm going to obtain it and connect it to the negative terminal, right? So that's up. I have powered up, right? Now I have to delete this wire because after we have all the wires are powered up, then we will powering up this one, right? Right. Now we have to give power to the ultrasonic sensor, right? So in this ultrasonic sensor, we have 4 pins, right? Maybe this pin is ground. That means we have to connect it to the ground, right? So then we have power pin here, and then this pin is connected to this one, right? So also on the alternatively, you can also obtain 5 voltage from the Arduino and connect it here. That is also possible, right? So also you can obtain 5 voltage from here, and you can obtain ground from Arduino and connect, right? So then after, what we have to do is we have to obtain these pins, trig pin, echo pin, right? So that means we have to select a trig pin and connect it to somewhere you like, maybe 8 pin, right? And then the echo pin is connected to the 9th pin, right? So that means we have wired up the input. That means we have wired up the sensor, right? So then if we turn on the power supply, then the sensor will be turned on, right? So that is all up the sensor, right? So then after, according to the sensor, right? So this is the sensor. This will detect the object's presence, right? So if there is any object is present, then the sensor will detect and it send to the Arduino, right? The signal will be sent to the Arduino, right? So then after, the Arduino will recognize the signal, and then it will put orders to the motors, right? So motors, that means the LED bulb. Here I have LED bulb, 2 LED bulb, right? But actually we will not going to connect LED bulb. Actually, what will we have to do? We have to obtain a motor controller, right? And then we have to wire this motor, and we have to wire this motor. We have to obtain this motor here and this motor there, right? So then we have in pins. That means in 1, in 2, in 3, and in 4 pins, right? So for that, right? For that, I have connected the first pin as an LED bulb, right? So the third pin as a LED bulb right here. I'm going to change its color, blue and red, right? So can you understand this thing? Right, I have changed because in order to show this simulation, I have simply replaced in one pin to an LED bulb, red LED, in 3 pin to a blue LED. That's up. That means you have to obtain. That means you have to obtain, right, the second pin, and then you have to connect it to the this pin, right? So then you have to obtain this pin and connect it to the third pin, right? That's up, right? For that, instead of that, because we don't have these components in the software, that is why I have replaced this component to a LED bulb, right? So what I have to do, I have to delete these things, and then I have to connect this one to a LED bulb, right? So I have to obtain a LED bulb. That means I can connect the second pin, second this one to the LED bulb, and then I have to ground the LED, right? So then I have to obtain this one and then connect it to this one, right? So then after I have to ground it. Right? This is the wiring, right? Instead of wiring the LEDs in actual situation, what will you do? We have to connect this one to the where? In one pin. The third pin to where? In 3 pin. So can we make this one to this one? That also can be possible, right? So I'm going to connect this one to, so that may you can understand, in 1 and in 3. So in this Arduino first pin is connected to the in one. The Arduino's third pin will be connected to the motor controls in 3 pin. Right? So did you understand? That is what we are going to connect, right? So that is up, right? And also we have to connect the second pin to the in 2 and fourth pin to the in 4 pin, right? So that is very, very simple thing. Right. After we have wired these things, we have to program it. Right. So the program is very simple. Right. The program is very simple. That is why we have to code. Right. So here we have to click this one, and then we have to delete the existing code. Right. And then we have to create a new code. Right. For that, this is very simple. Right. What we have to do, right? We have to create variable. Right, we have to create a variable called whatever you may call it as a sensor variable, right? Right, okay, right. So first of all, you have to create that this block. That means in variable we have to create this block and then set sensor variable to 0, right? That means initially the sensor value will be 0, right? So then after we have to select another one and place it here, right? Then set again, after set sensor to what? We have to select the sensor to the read 8 and 9 pin, right? So that is what I'm going to do, right? So I'm going to, right, insert it as a read ultrasonic distance sensor, right? So we have to select the sensor pins. These are very simple things, right? You know that ultrasonic distance sensor only trigger pin. What is the trigger pin we have? Here we have connected the trigger pin to, we can see that this is the trigger pin, right? So the second one is connected to what? You can see that this trigger pin, maybe that is why we use color codes, right? So this trigger pin is connected to 8th pin, right? So I can increase the size, right? This trigger pin is connected to the 8th pin and echo pin. Here, if you use 3-pin sensor, you have to select this as a same trigger, But if you use 4-pin sensor, 4-pin ultrasonic sensor, you have to select this as different, and then that the fourth pin, that means the another pin, echo pin, is connected to the ninth one. Also, units are in centimeters, right? So then we have to assign the values, right? So we have to assign this one, this values, right? That means the sensor's value is assigned as a read pin values. The sensor, the ultrasonic sensor's distance will be calculated and assigned as sensor values, right? So that is up. Then after we have to insert a control, right? In control we have to insert a if function, right? If and else function. We have to simply click and drag there, right? So after we inserted this if function, right, we have to go for the this one diamond pin, diamond part. So diamond part we have to select the met function, and then I have to insert this function, right? So you can make this one, right? So here what we have to do is we have to make this sensor variable, right? That means this variable sensor, this variable, right, is less than 20 centimeter, right? That means the sensor value, the sensor will detect the object. If the object is present within 20 centimeters, what the robot has to do? The robot has to turn right side, right? So that is why we are coding like this. That means you can simply see that sensor is less than 20, right? That means the sensor, you can see that the sensor is read ultrasonic distance sensor on trigger pin and 9, right? So this distance, right? So the distance is less than 20 centimeters. If so, we have to drag here and drop there. So if the sensor is less than 20 centimeter, right, what the code has to do? It has to turn right side. For that, for turning to the right side, we have to code here in this area, right? Else mean the sensor's object, right, is not detected within this range. What will have to do? The robot has to run in forward direction, right? So that way we have to code here. Forward direction code will come here. Rightward direction will come here, right? So this is simple. So up to now, do you have any problem? Right, Hiviru Sananayake, just ask me, do you have any problem? Can you understand this, or do I have to tell it again? Can you understand?
Can, sir.
Sorry, I didn't get you.
Can understand, sir.
Okay, fine. Then we can move to the other area, right? Right. So if the sensor, that means is detected, that means that if any object is detected within 20 centimeter, right? That means our robot has to turn right side, right? So for turning the right side, we have to go to output. That means we have to set output parts. These are the input parts, right? Now we have to deal with the output parts, right? For that, we have to set output, and then we have to select the pin, right? So pin means what? This is a case, right? That means the sensor is detected any object within this range, right? That means the robot has to turn. For turning on, what we have to do? We have to only power up this one. That means in one only give the power, and then all the other in 2, in 3, in 4, all are should be 0. In one only 5 given 5 voltage, others are 0. That means the right side motor, right? Right side motor will be stopped, and the left side motor will be rotating, right? That is why we are going to do. So simply, so you know that in1 is connected to this LED, right? So I'm going to give the power to the Arduino's first pin. Right? So I'm going to set that set pin, right? Set pin. That means set Arduino pin, right? Set Arduino. How many? What is the number? The number 1 pin, right? So the number 1 pin should be high. If the sensor is detected any object within this range, the set pin, Arduino's first pin should be high. That means this one is giving 5 voltage, right? So this 5 voltage will be coming through the LED bulb. That means the LED bulb will be turned on. And also we have to be aware about the other side also, right? So while we set that, we have to set also the second pin as well. Sorry, the third pin as well, right? The third pin has to what? Has to be low. That means the sensor detected some object, right? So that means the robot has to turn, right? So turn right what? Right direction. So that is why I set the third pin to low. And also, of course, you can set the second pin to low, and the other one, fourth pin also has to be low, right? So this is, so you can simply see that this Arduino's set number 1 pin is connected to the in1, third pin is connected to the in3, second pin is connected to in2, and fourth pin is connected to the in4. So that is why I have connected like this. So this is what happen if the sensor is detected. What happen if the sensor is not detecting the object? So can you answer, Sandali Samarasinghe? Can you answer me? What happens if the sensor is not detecting any object within this range, within 20 centimeter? The sensor is not detecting, right? So what will happen? What our robot has to do? Can you tell it to me? That means we have a sensor here, right? So the sensor is not detecting any object in present here. There is no object within 20 centimeter, right? So what will happen? The area is free to move. That means the robot can move freely, right? So what will happen? What we have to code? What we have to code? Sorry, your voice is not clear. Increase the sound a little bit. Yeah, tell me what the robot has to do. Yeah, the robot has to move forward direction, in forward direction. That is what we have to code, right? So we have to copy all these things, right? And we can easily duplicate here, right click and duplicate this one, and we can paste it here, right? Simply paste it here, right? That means the pasted items are in else section. That means the sensor is less than 20 will come here. If it is not less than, what will happen? The robot has to move forward, right? In order to move the robot forward, what we have to do? We have to give power to in1 and in3 pin, right? That means the motor will be running in forward direction. Both the two motors will be running in forward direction, right? So in1 and in3 has to be powered up. For that, what we have to do? we have to set in 1 pin high and in 3 pin also high. This is the logic behind it. And also set 2 pin low, set 4 pin low as well. Right? This is the code, right? So if you you can simply check it, right? So that is why I used the LED bulbs for you to check. But actually, if you have this code and all the things, you can work easily, right? So I'm going to simulate this one, right? You can simply click start simulation, right? So after you click the simulation, you can see that the sensor. So I can make this a little bit bigger, right? So if what happen if we click here, right, and then right, so this is the object. That means you can see that the bulb is turned on, right? So this bulb is also turned on. This one is also turned on, right? So if any object is present while the robot is moving, if there is any object is present, what will happen? Within, you can see that within this 20 centimeter range, right? So if it is nearing, right, you can see that the bulb is still turned on. That means the robot is still moving forward, right? So then we reduce the size, reduce it further, furthermore, you can see that what will happen, right? Yeah, that means that I think the LED is not working, right? So we have to encounter the problem. We will find out, huh?
So the wire is not connected from the buzzer. Sorry, the power supply. The positive wire.
Yeah, in this case, yeah, of course, the power is not connected, but the Arduino will provide in this software, right? Actually, in this software, Arduino will provide the power, right? So we can connect it here. Stop the simulation and connect, right? Right. Now we can see the simulation. Yeah, now it works, right? Fine, that's fine, huh? That's fine. That is very good. Huh? Who told me the answer? That is pretty amazing, huh? Right. Here we can reduce the object and see, right? So if the object is near, that means nearing, the robot is moving, right? So you have to imagine that what will happen. The robot is nearing, and then the object is present. The bulb should turn off, huh? Right? So it is present, right? So the bulb is turned off, right? You can see that, right? So why the struggle is happening? That means the not working properly. We have to insert a delay. That means we have to insert a time here, right? So then only it will work. And for that, I'm going to insert. So you can see that after I have turned the obstacle nearby, then after 2 or 3 seconds, that LED is turned off, right? For that, we have to insert a delay function, right? So I'm going to stop here and go to the code. This is very simple, right? So I have to insert a delay, right? Control, and I have to insert a wait second, right? So wait second, I can simply click maybe in milliseconds, and I'm going to increase this one to 100 milliseconds. Similarly, I have to right click and duplicate this one, and I'm going to insert here as well. Right now, the code will work fine. Right, right. So we can increase it and select it. So right now you can see that. So if the object is nearing the this one, then what will happen? The LED is turned off, right? So this is how you can test, right? So this is the code, and this is how you can test, right? So if you have any difficulties while understanding this one or problems, anything, you can ask it to me. If you have any problem.
No, sir.
Right. After we have coded this one, right, what we have to do? Yeah. What is the problem?
So is it okay to like connect the batteries while we connect the Arduino to the computer both together?
But at the same time, it is not possible. Huh? That means you can't connect the battery and the USB power at the same time, right? But you can change it. That means you can remove the USB cable from the Arduino and give the power from battery to the Arduino, right? That way you can work, but you can at the same time you can't connect. That is the problem, right? That is fine. Huh? Asking questions is very likely for me, right? That means if you are asking questions, that means you are really dealing with those components, right? So ask me questions, right? Right. Now, after we have coded this one, what we have to do, we have to click this one, blocks plus text, right? So we have to click this one and we have to select block plus text, right? Here, this is the C++ code, right? So this code, we have to copy, select all and copy, right? So you can see that in sensor, that means the sensor's initial value is 0, right? So then the signal pin, right, is defined here, and then the pin mode, that means the trigger pin is selected as output digital, right? That means these are the code. These are simple thing you can learn also, but here I'm really focused on this block programming, right? So hope you know that. Right, this is the code. You have to select all and copy the code, and you have to open your Arduino, right? You have to open your Arduino. Here, so then the robo will look like this. So this is the, maybe I don't know, this is the wiring diagram or not, right? We can check it, right? This is the, you have to focus, here, right? Here in this picture, we have to focus a bit, because here you can see that the battery is giving power to this one, this motor controller. That means the positive is connected to the 12 volt side, and the ground is connected to the ground side, right? So also we have another 9 volt battery here, and it is giving the power to the Arduino, right? So what you have to do is you have to delete this battery, right? We don't need this battery, and we can power up the Arduino from this one, this motor controller, right? So what we have to do is we have to obtain a red color cable and obtain and give the power to the Arduino. Maybe you can see that in Arduino there is a pin called as V in, right? In V in pin you can give power, and also you have to insert another wire in the ground pin, in the ground terminal. You have to insert another wire also, right? Another wire also you have to insert, and then you have to connect it to the ground pin, G and D pin, maybe written as G and D in your Arduino. That means you have powered up your Arduino. That is the way you give power, right? So this is the wiring diagram, right? So this is the actual wiring diagram, because we don't have the uh, motor controller in our Tinkercad software. That is why I used LED bulb, right? So, but actually this is the case, right? This is the case. You have to connect according to this diagram, right? So these are simple. Coding is the problem, right? Most of the students, even when A-level students or the university students, are having difficulties in coding, right? So for you, for I have simplified the coding. Why? How I have simplified the coding? By using the block plus text, this one, right? So you can work with these block diagrams. These are very simple things, right? So if you know about the basic things, this is very easy, right? So after this one, you can copy the code and paste it in your Arduino. If you have any difficulties or problems, you can simply edit this block diagram and then obtain a code from here, and then you can select all, copy the code and paste it in your Arduino. These are simple things. Right? Now what you have to do, you have to select all this one and delete. And now we have to paste our code in our Arduino software. Right? After that, we have to save the file. Right? We have to click save as, right? And save as our file wherever the place you like. Avoid obstacle, right? Obstacle avoiding sensor. You can save it. Now what you have to do at this stage, if you are doing really practically, what will you do at this stage? Tanishan, can you answer me?
No.
Yeah, what will you do at this stage after you have pasted your code? What is the next objective?
We want to paste it.
Yeah, we have pasted the code in the Arduino. What is the next thing we are going to do? Right, that is very simple. We have to obtain the USB cable, right? You have to obtain a USB cable, right? That means you know that the Arduino cable, right? So you know that this cable, right? So you know that this is our Arduino cable, right? So you can simply connect this side to the Arduino and this side to your computer, right? So then after you have connected that one, you can upload the code, right? So you can click upload. After you have connected that one, you can upload the code, right? After you have uploaded, what will you do, Binuka? After you have uploaded the code, what will you do?
We should test it.
Sorry,
So we should test it.
no, I didn't get you.
So we should test the
Your microphone is not clear. That is the problem.
shall I type the answer then?
Okay, fine. After we have uploaded the code, what will you do? I'm asking questions according to your question because you asked the question previously. Can we power up the USB cable and battery together? Right? That is why I'm asking question. Yeah, we have to test it, right? So for that, in order to test it, right, we have to remove the USB cable. That is the next task, right? We have to remove the USB cable, right? So we have to remove this USB cable, and then now we will have our robot, right? So then we have to insert the battery. That means we have to insert the Arduino's in pin, right? So that means we have to power up the Arduino. So in here we have in pin, right? So you can see that in power section in Arduino Mega, you have V in pin, right? So in V in pin we have to give power, right? So we can obtain V in pin from where? From the motor controller, right? From the motor controller, it has a 5 voltage output, and then we have to obtain it, and then we have to connect it here, right? So after you have connected, you can test it, right? That means the robot will run and you can test it. This is simple. So do you have any problem? Because this one we have 5 days until our next class, right? Monday to Friday. Within these days, you can practice these things, right? So you can code differently. That means I told you to, if there is any object is present, that means the robot has to turn right. What I did here. You can change it, right? So you can change it. If there is any object is present, the robot has to turn left side. So how can you turn this? So these are playing games, right? So you can simply change the code and see what will happen, right? For that, again, you have to edit this code. No need to retype the code. You can just simply edit the code, right? So for that, you can simply set pin and play around with these things, right? So you can simply change the set pins and all the things, and you can obtain the code. After you have obtained the code, you can open up Arduino and save it as another file, and then you can upload it and test it. This is the practice, right? So we have to change it, write the code, obtain the code, upload it to the Arduino, and then we test it, and then we change it, right? Write the code, obtain the code, upload it to Arduino, and then we test it. This is the way we learn, right? So if you practice these things like I told you, you will learn a lot. That means you will invent new things, right? So do you have any problems up to now? Do you have any problem? Because you have to get all the knowledge about these things, right? So because in future we will learn about uh, Bluetooth control and control robotics, right? So those kinds of steps will be learned in our upcoming lectures. So you have to be aware about these simple things. Bluetooth controlling is another section, right? So that means that is another part, right? That means we can control our robot by using our smartphone. That is another sector. That is also codeless, right? So we are not going to use any kind of codings, right? But we are going to work, right? So for that, I'm going to give you another task, right? So can you think, right? So can you think a line following robot? Can you think about a little bit about the line following robot? That means I can show it to you, right? So line following robot, right? So the robot will look like this. Huh? So this is the simple robot that you can see here, right? So this is the line following robot. You can also make that. That means you insert a tape on your floor, right? On your floor, you insert a tape, whatever you like it, right? So then the robot has to follow the path, right? This is the task, right? So the robot has to follow its path, right? So for that, we have to have two infrared sensors. That means IR sensor. The sensor that we used earlier in our car robotic system, you know that the sensor, right? So we have to use two sensor, right? In the sensor, you know that, right? You know that it has three pins. One is for 5 voltage, another one is for GND, that means ground, and the final one is for out. And also the sensor will also have three pins, right? So you can simply power up the sensor 1 and the sensor 2. You can simply power up, right? That means you can give 5 voltage and ground. Now you can obtain out signal, right? So you can obtain out signal and connect it to your Arduino, maybe whatever the pin you like, 1 or 2 or 3, whatever you like. But be aware about that. It has to connect what pin. What pin will you connect? That means analog or digital. We can connect whatever the pin, right? So whatever, sorry, what not whatever, analog or digital pin, either one of them, right? So because this one, right? So best is to select digital, right? So you can select the digital pin. If the voltage is appearing, you can go for it, right? So that is that. So here you have a toggle knob here in order to change the variation, right, of the sensor. And the sensor will send the signal from here, sorry, from this one is the trigger and this one is the echo, right? Similar to our ultrasonic sensor, right? So this one is IR, giving signal and obtaining here, right? So if the wall, sorry, if the floor is in white color, that means the all the infrared rays will be emitted. After it is emitted from the floor, right, the sensor will absorb the rays. That means it will send the signal to the Arduino, right? That means you will get the positive signal, same as this one. So how can you think and make the robot work? How can you make it work? Because if two sensors are detecting positive and positive signals, then the robot has to move forward direction. Can you get my point? If this sensor is also detecting, this sensor is also detecting, that means the robot is in place, right? It's in place. That means the robot is in place, right? So then the robot has to move forward, right? So if the robot is slightly turned on rightward, that means what will happen? The sensor will not detect the signal. The sensor, that means the sensor, this emitter will emit the signal, and the black line, that means the black tape will not going to emit the signal. That means it will absorb all the infrared rays. Then this trigger, this echo will not going to receive. That means the sensor will give zero voltage, but this sensor is still here. So then it will give positive. So it will give positive 5 voltage and this will give 0 voltage, right? So that what you have to do, you have to program your robot to slightly turn on what direction? Left direction, slightly, slightly turn this direction until it comes to the original state. This is same as you can code as well. If it is turn, this sensor is not detecting, that means the robot has to turn in right direction. Then similarly, you can code this, right? So just think about this one, right? And write a table as I type here, right? So you can just write a table, right? So according to the table, you can write the program, right? So that's up to the class, right? So in our next classes, we will learn those things, right? Right. Do you have any problems or doubts? Right. Then we will wind up the class and practice these things, right? Right. Right.